Hello everyone. Today I'm starting a new playlist that is data structure implementation. In this playlist, I will be showing you and I'll be helping you to understand the concepts of how each and every data structure is implemented. The language that I will be using for implementing data structures in this playlist is C++. So make sure you understand C++ language. Today, I will be talking about linked list and we'll be implementing linked list. So the linked list that we'll be implementing is a single linked list or a singly linked list, as you can see in the image. Let's move to the prerequisites. So the prerequisites of learning and following along is C++. You should have basic understanding of how C++ works, the basic syntax, that is all. Two important things which we will be using are structure and pointers in implementing linked list. How do we store information about a student? So a student, let's say, have three things: name, age, and grade. For storing the name, there is a primitive data type in C++ that is string. For storing the age, we have integers in C++. And for storing the grade, we have character in C++ to store it. But a student will have all these three things. And we do not have any student type of primitive data type in C++. We have to create our custom data type. So in this custom data type, we will have name, we will have age, and we will have grade. So name will be a string, age will be an integer, and grade will be character. The C++ code for this is shown, which we can create using the struct keyword, followed by the name of the structure, which is student in our case. And then we have mentioned the primitive data types inside of it, which we want to group together. So now we have created a data type which is student, which will have these three properties, that is name, age, and grade. Moving on to pointers. So pointer is a variable that stores an address of another variable. It is very simple. Pointer is nothing but a variable that stores address of another variable. Let's try to understand this with an example. So let's say we have a variable a which has 5 stored in it, and it will have some address, let's say 100 in our example. And let's say we have another variable which is named as ptr, and let's say it has address of 200. So now if we want to create a pointer which will point to a, then all we have to do is we have to store the address of a inside the pointer variable. So the address of a is 100. If we store that in the pointer variable, then this pointer variable will start pointing to a. And we can manipulate the data that is inside a via this pointer as well. Let's see the code. So in the code, I have created an a variable with value of 5, and then I have created a pointer, and that pointer contains the address of a. So this pointer is now pointing to a. And as you can see in the next line, that using this pointer variable, when I dereference it, then I was able to change the value of a. So now that we have brushed the structures and pointer concepts, let's jump into the implementation of linked list. So a singly linked list looks like this. Don't worry too much when you look at the whole linked list. It will be very simple, and I will be taking one step at a time. So here, just take a look at the two pointers that we have, which are very special, a head pointer and a tail pointer. So the head pointer will always be pointing to the very start of the linked list, and the tail pointer will always point to the very end of the linked list. And also notice that every node also has some address, and that address is the address of the node it is pointing to. So in a linked list, there are two sections in a node. One is the data section where we are storing data such as 10, 20, and 30. And other is the address section where we have stored the address. Also notice that the last node in the linked list is pointing to null, because after the last node, there's nothing to point to. Hence, we are pointing to null. to indicate that this is the end of linked list and there's nothing more to point to. Hence it is null. So a node consists of two things, which is data and address. Now a data we can represent in an integer if we have integer data, and the address we can represent via pointers. But we do not have any data type which has both of these things. Here we'll be using structure to create one. So let's jump into the code to create this structure. So here I have some boilerplate code written already. I have included IOStream, I have used the namespace std, and I've written the main function which is returning 0. So as we saw in the slide, we have to create a node structure. So let's do that. We'll use the struct keyword. We will name it as node with a capital N. It ends with a semicolon, important. Then we'll store the data as an integer, and I'll store a pointer known as next. So the important thing here is that the next pointer is of type node, because every node points to a node. Hence it is important that the pointer is of type node. Okay, so here we have created a simple structure which is representing a node. By default, this structure will not consume any memory until unless we explicitly initialize it. Let's say I initialize it with something like this. So now we will consume memory. Now this will consume memory. But if we do not have this line, it will not consume any memory, because think of this as a data type. Let's say we have integer data type, float data type. So these are primitive data types that we have in C++, and they do not consume any memory by default until unless we explicitly define a variable like int a, etc. So the same way, think of node as a data type, as a custom data type that you have created. And until unless you explicitly use it to define something, it will not consume any memory. So this will not consume any memory. Now this is a very simple linked list which only has one node in it. And you should notice that if there is only one node, then that node is pointing to null. It makes sense. And the head and tail will also point to the same node. And this is a very special case. Head and tail will point to the same node only when the size of the linked list is 1. So let's try to create this linked list and also create these two pointers, head and tail, in our code. So I will go ahead and remove this. So let's create two pointers, head, and point it to null. And I'll create another pointer that is tail. It'll point to null. Now I will run a while loop simply because I want to keep taking input from user until the user wants to quit. So I will take an input from user, cout, the data, enter -1 to quit. So any data that user enters, I will be putting that in the node. And if the user enters -1, then I will assume that the user does not want to create further node in the linked list and the while loop should break. So if d is not equal to 1, that means I have to do some processing. And if d is equal to -1, so then I have to break out of this while loop. Now I have to create a node star and new node. So I've used this new keyword to allocate some memory from heap, and this pointer will point to that memory in heap. Okay. Now let's store the data in the node. So user entered this d value and now it is stored in the data section of the node. There is one more way where we can store this data, which is a bit more intuitive than using this arrow method, which is I will dereference current and then I'll point to the data and then I'll store the data in the data section. So this is more intuitive. What I'm doing here is I'm dereferencing into the current node and then I'm going to the data section and I'm storing the data. But generally, I prefer the arrow method as it is simpler to write and it is convenient. So there are two sections in a node, which is data and next. I have stored the data section with the relevant data given by user. And now the next section should point to null. So I have just created a node wherein I've entered the data and it is pointing to null. Now, one thing that is left is the head and tail pointers are still pointing to null. They're not pointing to this node that I've created. So let's do that. Now, head is null and then tail is null. So this scenario will only arise when we do not have any node. And that is the current scenario in linked list. We are creating the first node. So now we have to point the head to current and also the tail will point to current. So head and tail are now pointing to the current. So basically, whatever we saw in the slide, we have implemented that. We created a node, we stored the data entered by user, we pointed it to null, and finally, we also pointed our head pointer and tail pointer to that node. Now let's jump back to the slide. So now we have already implemented this linked list. The only thing is that it at the moment has one node. Now, how do we add another node to it? We add another node by simply creating a node. Since we have written the code in a while loop, in the next iteration, we will be creating another node. So now we have to implement two things. First is we have to point the first node to the second node. And how are we going to do that? We are going to store the address of second node in the first node. And after that, the second thing is we have to move the tail pointer to the end of the linked list. Notice that to move the linked list, it was simply to change the data that was stored in it. Earlier, it was storing 100 in it. Now simply we had to store 200 to move it to the end of the linked list. Now let's try to implement this behavior in the code. So here, during the next iteration, we will be creating a new node. The data will be entered into the node and the current next will be automatically be pointed to null. So here the head is not null, hence the code will not hit here and we have to write an else for it. There were two things that we had to do. First, we have to make the first node point to the second node, which should be simple because tail is now pointing to the first node. So we can use tail next and we can store the value of current here. Now, what happens here is that tail next was basically the next of the first node. And in the next of first node, we stored the address of the new node, the latest node that we created, which is basically the second node. So the first node is now pointing to the second node because of this line. And now all we have to do is we have to move the tail pointer to the end of the node, which is basically just to store the address of current in the tail pointer. So these two lines will make our code work as we saw in the slide. And our linked list implementation is completed. Let's try to execute this code. So here we have that file. Let's try to compile it. Yes, it is getting compiled as expected. Let's try to execute it now. So here we can enter the data as 10. We can enter 20, 30, 40, and 50. Then I want to stop. So our code is working fine. everything is working as expected. Now the next thing, I will be adding a display function that will be showing the contents that I just entered. Wait for that until the next video and I'll be showing that how to do it. So we have finally implemented the linked list. The code for it I'll be attaching somewhere in the description. I would suggest you go ahead and try to implement this yourself and tweak with the code that I have shared. Make sure to like, share, and subscribe. If you have any questions, put them down in the comment section and I will answer each and every question. I'll see you in the next one.